Okay, we're going to do a few examples with dilations. So a dilation, remember, is when you change the shape, the size of the object, but not the shape. So when you do a dilation, you're actually changing size, but not shape. So it's going to stay the same shape. We talked about dilations. Dilate your eyes, enlarging photographs. You have enlargements and you have reductions, okay? So let's look at these. This is a dilation of, for example, of 4.5. So if I want to find a dilation of 4.5, what am I going to do to all of these coordinates? I'm going to multiply every coordinate by 4.5. So if I want to take I is at -1, 0, M is at -1, 1, and B is at 1, 0. If I want to dilate this with 4.5, that means my K is 4.5. That is my scale factor. Okay, 4.5 times -1 is -4.5, and 4.5 times 0 is 0. For M, 4.5 times -1 is -4.5. 4.5 times 1 is 4.5. And for B, 4.5 times 1 is 4.5, and 4.5 times 0 is 0. So that is my new set of coordinates with a scale factor of 4.5. Now that is an enlargement, okay? That's an enlargement, because what happened to the figure? It got bigger. It got bigger. So that's an enlargement. Now let's look at something where we're doing a reduction. Okay, so I'm going to come down here. Now I'm going to do a dilation of 0.25. Okay, so K is 0.25. Now since K is less than or equal to 1, I have a reduction. Okay, K is less than or equal to 1, so I've got a reduction. So I'm going to take all of these coordinates. J is at 0, 4, V is at 1, 5, G is at 3, 3, E is at -1, 0. And I'm going to apply, okay, I'm going to, sorry, and I'll write J again down here. J is at 0, 4. I'm going to apply my, again, this should have been primes here because these are images. I'm going to apply my dilation rules. Now, since this is a scale factor smaller than 1, this is a reduction. So I'm going to take 0.25 and multiply it by everything. What's 0.25 times 1? 0.25. 0.25 times 5 is 1.25. And again, you'll have a calculator on the exam or the quiz. 0.25 times 3 is 0.75. 0.25 times 3 is 0.75. For E, 0.25 times -1 is -0.25. 0.25 times 0 is 0. For J, 0.25 times 0 is 0, and 0.25 times 4 is 1. So there are your new coordinates. And that is how you do an enlargement and a reduction, just given the scale factor. You multiply it, okay? So let's actually look at a dilation here. We'll look at two different dilations. We're going to look at number 6 here, which will be an enlargement. Why is it an enlargement? Because the scale factor is larger than, I'm looking to see if I have another one. Yes. The scale factor is larger than 1. So let's do an enlargement here. K is equal to 1.5. You can see that right there. They tell you that's your scale factor, okay? So I'm going to do my original points first. I'm going to graph those first. My original points are going to be J, which is at -1, -1. So this is your original J. U is at 1, 3. So that's your original U. And W is at 0, -2. Okay? So that is your original figure. We have J at -1, -1, U at 1, 3, and W at 0, -2. I'm going to go ahead and connect these so you can see it's a nice little happy triangle, just like happy trees. And we're going to dilate this with a scale factor of 1.5. So that's basically meaning we're going to make this 1.5 times. Let me straighten that up because I'm OCD. 1.5 times the other one. So let's start off to the side here. The original J is at -1, -1. The original U is at 1, 3. The original W is at 0, -2. So what I'm going to do here is I'm going to dilate these to J prime, U prime, W prime. Okay? So I'm going to take 1.5 and I'm going to multiply it by everything. So -1 times 1.5 is -1.5. -1 times 1.5 is -1.5. I'll expand that out a little bit. Sorry, that looks kind of sloppy. 1 times 1.5 is 1.5. 3 times 1.5 is 4.5. I should have given myself more room. 0 times 1.5 is 0, and -2 times 1.5 is -3. Okay, so now I'm going to graph these. I'm at -1.5, -1.5. That's going to be my new J. -1.5, -1.5. So my J prime is right there. U went from 1 to 1.5, 4.5. So I'm going to go over 1.5 and up 4.5. That's my new U. The new U. And W went from 0, -2 to 0, -3. So that's my W prime. So I'm going to now draw my other triangle, my new one. And you can see that that is a symmetrical dilation almost. Remember, we dilate everything around 0, 0. So that triangle is an enlargement. Let's write that word again, enlargement, because K is greater than or equal to 1, or greater than 1. If K is greater than 1, you've got an enlargement, so it got bigger. Let's look at a reduction. If I can ever get these papers out of here. Let's look at a reduction. We've got some on the next page. All right, let's look at a reduction. All right, what could be kind of tricky here? Oh, these are all boring. These all are 1/2. You just take half of it. How boring. Okay, so when we look at a dilation, let me see if I've got it here. That's 3/2. Okay, so I'll do the 1/2. I'll do 11. I'll play along. So we've got a scale factor here of 1/2. So K is 1/2. Since K is less than or equal to, or sorry, since K is less than 1, then we have a reduction. K is less than 1, we got a reduction. Okay, I got to make sure I didn't write equals to on the other one. Let me go back and correct that here. Let me make that correction here. This right here would be K is less than 1. Okay, not less than or equal to. That's my mistake. Because what happens when K equals 1? K equals 1 means that you're not changing the figure, right? Okay, so K is, let me rewrite that. I'm real picky about having the correct notation. K is less than 1. We got a reduction. So let's look at the original points. I've got D. D is located at 0, 2. I've got W. W is located at 5, 4. And then I've got L. L is located at 1, 2, 3, 5. And I want to reduce this by a half. So I basically want a triangle that's half that size. Okay, so we're going to dilate. D prime, W prime, L prime. All right. Let's look at D. Let's apply the 1/2. Basically, that means, remember, we're multiplying everything by 1/2. So what's 1/2 times 0? 0. What's 1/2 times 2? 1. What's 1/2 times 5? 2.5. What's 1/2 times 4? 2. What's 1/2 times 1? 1/2, or 0.5. And 1/2 times 5? 2.5. So let's graph our new one and see where it is. So the new D is at 0, 1. Okay. The new D is at 0, 1, so that's where your D prime is. The new W is at 2.5, 2. And the new L is at 0.5, 2.5. That's L prime. So here's our picture. That triangle is exactly half the size of the other one. Now, you're like, why is it moving? It's not really moving. Remember, everything's dilated around here. I want you to look at this. Imagine that you're at perspective, like this is your eyeball. If I look at this, do you see how these are nicely connected by a line? This is my line of vision. Now can you see that we've taken the line of vision and shrunk it? Okay? We've taken the line of vision and shrunk it. It's getting closer to it, but it's getting smaller. So that's what a dilation looks like. And again, that's a reduction. K is less than 1. So that is what you're looking at with the dilations. Now, on the dilations, you might have to look at something and tell me what was the rule. So let's look at number 16. Write a rule to describe each transformation. Well, let's write a rule. I went from this U to this U. Okay? Now we're doing dilations, so you know we're doing like dilations. I went from this K to this K. And I went from this F to this F. So the question is, what was my scale factor? Well, first of all, we have to look at this. Did these coordinates get bigger or smaller? Well, think about it. Let's look at the positive case. I went from 0 to 0. I went from 2 to 3. That got bigger, right? From 2 to 3, that got bigger. So this is going to be an enlargement. Okay, this is going to be an enlargement because we're getting bigger. The values are getting bigger. How do I figure out what we did? Well, let's just take U. Let's just take 1 here. I went from -2 to -3. So I took -2, right? And I multiplied it by some scale factor, I don't know what, some K, and I ended up getting what? -3. I took the original, multiplied it by some scale factor, we don't know it, and got -3. Well, now it's just simply algebra. So let's solve both sides. To solve for K, I divide both sides by -2. So K is equal to negative over negative is positive 3/2, or 1.5. So there's your scale factor. That's it. That's all you do. You take one of the originals. Could I have picked any of these points here? Sure. Not the zeros, because that won't help. But I could have picked any of these and I would have gotten the same answer. What if I did -1 and 1.5? Well, I started at -1 and I multiplied it by some K value, right? And I ended up getting what? -1.5, right? Okay, solve for K just like we always do. So I'm going to divide both sides by -1. And what do you get? K is 1.5. Same answer. So that's how you're given a set of points and you can actually find what your scale factor is. You have to determine, what did I multiply the original by to get the new one? Okay? So the last thing I'm going to show you is dilation rule here. So the question is, what do I do? How did I get from this one to this one? Okay? So for 21, we're going to say that the black one is the original and the blue one is the image, which means we are doing a reduction. Okay, so let's get the coordinates of the blue one first. The black one first. All right, so for the black figure, I have T, which is at 1, 2, 3, 3, 0. Excuse me. I've got P, which is at 1, 1, 2, 3, 4, 5. And I've got J that is at 0, 3. Where did I end up? Well, let's figure it out. T prime ended up, okay. Oh, and there's a K prime. Sorry, there's a K. I missed the K. Good job, Getty. Okay, or Stoughton. So anyway, the K is at 0, or sorry, 2, 0. The original K is at 2, 0. Sorry, I missed that coordinate. It's been a long day. All right, so T prime is right there. That looks like it's about what? 1.5, 0? Just your best guess. P prime is right there. That looks like it's about over 1/2 and up 2.5. 0.5, 2.5. J prime is at 0, 1.5. That's this one. And K prime is at 1, 0. So you can take any of these and do what we did above. So that let's start with t. For t, I started at 3, right? And I multiplied that 3, whoops, I'm sorry, it's off there. I multiplied that 3 by some scale factor k, right? I don't know what it is, but I multiplied the 3 by something, and what did I end up with? 1.5. So that's all I know is when I multiplied the original by k, I got 1.5. So let's solve for k, divide by 3. 1/2 out of 3 is actually 1/2, which is 0.5. So your scale factor is 0.5. That means that we've basically cut all these in half, and if you look at it, that's what we did. We went from 1 to half. We went from 5 to 2.5. We went from 3 to 1.5. We went from 2 to 1. So that's how you find your scale factor when you're doing dilations.